More than 80% of world trade by volume is moved by ships, and ships are by far the most energy-efficient mode of transport. In fact, there is a large potential for coastal shipping to replace less efficient but rapidly growing road transport. To make this prospect even more attractive, the maritime sector and its partners must pay attention to emissions and air quality, an area also likely to attract a lot more official scrutiny in the future. When a ship is docked, its energy requirement is typically met by onboard diesel-powered generators. This is not only an inefficient use of energy, but also results in emissions of greenhouse gases, local pollutants, and noise. Utilization of power from shore can eliminate these negative consequences. And shore power facilities are likely to become a lot more available as port and local authorities respond to the anticipated demand for charging onboard batteries for propulsion of battery hybrid ships and for fully electric ships. It's predicted that these will represent an increasing proportion of ships in the future. Where electricity is generated from renewable sources, shore power can be a very attractive zero-emission alternative. But so far, high investment cost and the lack of a clear business model for ports and ship owners have been cited as barriers for shore power. The Recharge project aims to guide the industry in overcoming these barriers and to aid in the wider adaptation of the technology. The project partners ABB, Cavotec, Port of Oslo, and DNV have set out to identify where it makes most sense to develop shore power infrastructure from an environmental and cost perspective. These days, the availability of sensors, connectivity, and software, combined with big data analytics tools, have transformed the way we generate, handle, and utilize data. In the Recharge project, historical AIS data, in combination with ship technical data and engine characteristics, are being used to pinpoint where in a port emissions take place, where the reduction potential is highest, and what kind of infrastructure needs to be developed to mitigate these emissions. Specific ships and routes that are eligible for battery propulsion have also been identified. A cost calculator has been established for the purpose of giving stakeholders a rough estimate on the investment and operational cost, return on investment, and emission reduction potential for investing in and utilizing shore connection systems. These new tools permit a more targeted approach when evaluating whether and where to invest in shore power infrastructure. With standards and an optimized approach to shore power in place, we expect an increase in both ships using and ports offering shore power. This will be a step towards future-ready zero-emission ports and reduced emissions from shipping in coastal areas. Shore power for more energy-effective and environmentally friendly shipping.